This is the solution video for section 4.3, problem number 4. All right, so section 4.3, problem number 4, the directions say, given f prime, find the x values where f attains local extreme values. Give the intervals for which f is increasing, decreasing. All right, so first of all, we have to recognize that we are given f prime here, right? All right, so that means all we want to do is we want to start by setting this thing equal to 0. So I have 1/2 secant of 1/2 x tangent of 1/2 x. All right, so we have this thing multiplied by this thing, so we're just going to set each thing equal to 0. So 1/2 secant of 1/2 x equals 0, or tangent of 1/2 x equals 0. All right, so we want to think about, when does secant of 1/2 x equal 0? Well, the problem is that secant is never equal to 0, because what does this thing really mean? It really means 1/2 cosine of 1/2 x. When does that equal 0? Well, that's never true, right? So we know that if we were to look at this, 2 cosine x equals 0, right? Whenever cosine of 1/2 x is equal to 0, the derivative would be undefined, right? All right, so we want to divide by 2, and we want to say, okay, cosine of 1/2 x equals 0. So when does cosine equal 0? Well, that occurs at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So I would say pi over 2 plus pi n for any integer n, right? But that means that's 1/2 x. And so x would be this thing multiplied by 2. So it'd be pi plus 2 pi n. So that'd be pi, 3 pi, 5 pi, 7 pi, right? Or pi, negative 3 pi, negative 5 pi, negative 7 pi, right? Now, look at our interval, negative pi over 2 to positive pi over 2. None of those are between negative pi over 2 and positive pi over 2. So that actually does not contribute any answers to when our derivative is equal to 0. All right, so then we look at this. Tangent of 1/2 x equals 0. All right, when does tangent equal 0? All right, tangent equals 0 when, well, remember, tangent is sine over cosine. So it equals 0 when sine is equal to 0. So that is at 0, pi, 2 pi, 3 pi, right, and so on. So 0 plus pi n. And so now I'm going to multiply this by 2. So I get x equals 2 times 0 is 0 plus 2 pi n. Right? And so 0 plus 2 pi n, well, what does that mean? That means that x is equal to 0, 2 pi, 3 pi, sorry, 0, 2 pi, 4 pi, right, and so on. So what's in between negative pi over 2 and positive pi over 2? Well, that is just 0. So x equals 0 should be the only number on our number line. All right, so now I go here, I put 0 on my number line. All right, so now on the side, I have 1/2 secant of 1/2 x, and I have tangent of 1/2 x. All right, so now I'm going to put a 0 on my bottom row, and I'm going to put nothing on my top row because it's never equal to 0. And then I want to make sure I include negative pi over 2 and positive pi over 2 so that I am not going outside of that window. All right, so now top row, pick any number here in, well, basically quadrants 1 or 4. So secant of 1/2, well, let's just plug 0 in. Secant of half of 0. So that would be secant of 0. Secant of 0 is positive 1, right? Because secant is the reciprocal of cosine. Cosine of 0 is 1. So that means this is positive. All right, the bottom row here, pick a number to the left of 0. How about, well, negative pi over 2. So I have half of negative pi over 2, so that'd be negative pi over 4. So tangent of negative pi over 4, that would be in quadrant 4, so that is negative. And to the right, like positive pi over 2, so half of pi over 2 is pi over 4. Tangent of pi over 4 is positive 1. So that means f prime, our derivative, is positive times negative, which is negative, or positive times positive, which is positive. So what does that mean? That means that f is increasing on the interval 0 to pi over 2. F is decreasing on the interval negative pi over 2 to 0. All right. So then that means if we think about what's going on at 0, derivative changes from negative to positive. So there would be a local minimum. So there's a local minimum at x equals 0.